All right, Algebra 2. Today we're doing 7-6 negative exponent rules. We touched on this a little bit. Here's your reference chart. Again, this is on previous notes. If you don't understand it, there are Schoology videos that go over each of these rules one by one. I'm going to start the notes today by simply just solving this. Negative exponents. This is a generalized understanding of how and what they come from and what they are. I like this reference sheet, but I'm going to just basically go into the examples since I've already taught this. For those who are wondering what this is saying, it's basically saying why is the rule for, let me show you. Like if I had this, if I had x to the, oh, that's not it. If I had x over to the 7th, let's say, x to the 7th, right, over x to the 5th. Why is the rule subtraction? Because the rule is 7 minus 5. The rule is 7 minus 5, which gives us x squared. Why is it subtraction? Well, check it out. If I had 7 x's on top, that's 3, 4, 5, 6, 7. That's 1, 2, 3, 4, 5, 6, 7. You see that? And then if I had 5 on the bottom, 1, 2, 3, 4, 5, and you divided them all out one at a time, check out what happens when you divide them out one at a time. They're canceling each other out. What ends up happening is, basically when it's all said and done, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. I need 7 on top. 7 on top. What ends up happening when you're all said and done, when you cross them out one at a time, there's going to be 2 left over. That's why we do this minus thing. And if it was flipped over, let's say it was flipped over to x over 7, we'd still maintain the minus rule. You go 5 minus 7, and you would shove this on top. It would be 5 minus 7 is negative 2. But then our rules for negatives are, when we don't like negatives, we go from top to bottom or bottom to top. So in this case, we have our x to the negative 2 in the numerator. So that means it's going to be shoved down to the bottom, and it's going to change. So I taught this on Friday. That's why I'm kind of going through it a little like this. It's not that big of a deal. Pay attention to how I solve these problems, and then let's get to it. So, yeah, let's just do this first page of examples right here. 5 to the negative 4 over 5 to the 8th. We're going to use the rule. This is negative 4 minus 8. This is negative 4 minus 8. So you end up with 5 to the negative 12. But we don't like negatives inside our numerator or denominator. So remember, we're going to switch it to the bottom. So in this case, we end up with 1 over 5 to the 12th. That's how that works. Negative 4 minus 8, negative 12. We don't like it up there. All right, negative 3 minus 5. Negative 3 minus, sorry, not just minus 5, but minus negative 5. Minus 3 minus negative 5. What happens when I have a minus minus? They turn into a positive. So negative 3 plus 5 is equal to 2. So I end up with 2 squared as my answer. Remember the rules when they're next to each other? When they're multiplying, you add them next to each other. So negative 6 plus 5. Negative 6 plus 5 is equal to negative 1. Negative 6 plus 5 is equal to negative 1. So whenever you have that, you're going to end up with 3 to the negative 1. But we don't like that, so we're going to switch to the sides. And we're going to end up with 1 to the 3 to the 1. And again, we don't like 1s in there either. So it kind of looks like that. I'm going to switch to blue. Let's check this out on how to solve this one. This is 4 to the 0, which anything raised to the power of 4 just results to 1. So 1 times 4 to the 3rd is 4 to the 3rd. This is 3 to the negative 6 raised to the power of negative 2. It kind of looks funky just because of like computer formatting, but it's actually looking like this. Negative 6 raised to the power of negative 2. And the rules we learned on Friday is you multiply these two. So you end up with 3 to the 12th. Same thing here. This ends up being 4 times negative 3. So we're going to end up with 2 to the negative 12. But we do not like that we don't like negative numbers for our exponents. So we're going to end up putting it in the denominator just like this. Pretty straightforward. I'm going to solve the next examples all in one video.